G'day from Australia. My name is Ashley Davis. Welcome to my talk on rapid full stack development. Through my career, I've worked with many different languages, frameworks, APIs, and things like that. Our industry changes quickly, but one thing that has remained constant for me is my quest to be a better developer. I've spent a lot of time thinking about how to be faster and more effective at software development, figuring out how I can be more productive, how I can get more done, and most importantly, how to get the right stuff done. I'm always looking for ways to refine and improve my development process. Today, I'm going to share with you some of the things I've learned and that helped me. I've also got a live demo in this talk where I'm going to give you a look, just a taste really, of some of the techniques that I use when I'm developing code. Before we get into it, I'd like to start with the tradition that we have here in Australia. I'd like to acknowledge the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. I'm the VP of Engineering at Hone. We are building products on the Algorand blockchain. I'm the developer of DataForge Notebook, which I'm in the process of open sourcing at the moment. I've also written some books. So my first book, Data Wrangling with JavaScript, shows JavaScript developers how to work with data. It shows you that you don't really need Python. You can get by with JavaScript. You just need to learn how to use it. I'm currently working towards a second edition, Bootstrapping Microservices. This is a practical guide to working with microservices, starting with nothing, creating a single microservice, scaling up to multiple microservices, and ultimately deploying your microservices application to a production cluster running on Kubernetes. I'm pleased to say that I'm working on a new book, Rapid Full Stack Development. It has the same title as this talk, so they're very much related. Rapid Full Stack Development is a book that will help you be a more effective and productive developer. Please check out the webpage. You can subscribe to follow what I'm doing with the book and keep up to date with it. Before we start, and to get you thinking, I just want to ask this question. What's the fastest way to write code? I don't actually want you to give me an answer to the question. I just want you to think about it for a few minutes. I will circle back to it soon, and I'll give you my answer to this question. What's the fastest way to write code? So what do we need to do to be faster developers? Rapid development isn't just about being a fast coder. By itself, being able to write code quickly, it's not a worthy goal. It's not even a useful goal. As a software developer, you need to be able to produce working and valuable code. Otherwise, there's no point being able to write code quickly. If you know how to produce code that is both working and valuable, and even if you can do that slowly, you're going to be able to outperform any other developers. Here are some of the key things we need to do to achieve rapid development. We need a streamlined process for creating and testing our code. We need tools that support us rather than hinder us. Our process also needs to be sustainable. If we burn out, that's going to be a huge derailment of our productivity. We should balance the value of our code against the cost to create it. It's important to prioritize our work based on its value to ensure that we're always working on the most valuable code that we could be working on now. But it's not just the value of the code that we need to consider. We must also balance the value of the code against the cost to build it. We should prioritize work not just by how much it is worth, but also how much we estimate it will cost to build. So code that is slightly valuable and takes a day to deliver can be higher priority than code that is extremely valuable and takes a month to deliver. We also need to minimize the time that we waste on things that we don't need to be doing. Software developers are masters of wasting time. Of course, we don't do that on purpose, but the nature of the game is that there are an infinite variety of distractions that are trying to derail our productivity, and we spend way too much time on things that just aren't very important. Here are some examples of wasting time. You've probably experienced some of these yourself. I know I have. We automate things that don't need to be automated. We use tools and processes that slow us down. We regularly create bugs that take time to fix. We waste time on code and features that ultimately will be used infrequently and sometimes not at all. And finally, we often burn time just trying to make our code perfect. To adopt the rapid developer mindset, we need to start with some honesty. Before we can reduce or eliminate the things that slow us down, we need to be able to recognize them and identify them. So you have to start to train yourself to be wary of things that are going to consume your time but are not really necessary. Before we can create a process around rapid development, we're going to need a guiding philosophy. Did you ever have the experience when you were coding for hours or maybe even longer, and then when it came to actually testing your code, you found that it just doesn't work? Or even worse, it did kind of work, but there was a bunch of lurking bugs in there that were later found by your users? Coding for a long time before testing is a terrible idea. And the reality is that software doesn't get created like that. Successful software development is done through an iterative and evolutionary process. Iterations help us to set a rapid pace. They are the beating drum that keeps us rolling forward. It's how we make incremental progress towards a larger goal. Diving into coding before thinking is often a big mistake, even though you probably know this already. But every time we start coding, it's still so tempting to get straight into the coding without doing any planning. This code first, think later way of working, it's just so prone to errors. And we need a way to regularly reassess what we're doing to know if we're heading in the right or the wrong direction. Iterations give us natural gaps in which we can review and plan our work and continuously reassess our direction. You can make your own system of iterations, of course, but I like to use the Pomodoro technique. That's the structure that I use for my own personal work iterations. Please look it up and try it out, and please don't be afraid to adapt it to your own needs. Having thinking and rest embedded in our process gives us the best chance of making the best decisions and still maintaining rapid bursts of coding activity and getting lots of work done. Regular breaks makes our process sustainable, giving us the energy we need to get through the working day. Many developers spend much of their time debugging broken or badly behaving code. Now, to some extent, debugging is necessary. We all know that. Debugging is always going to be part of the job, but there are also many problems which can simply be avoided if we take a little more care. This boils down to what is essentially my most fundamental rule of software development. Keep your code working. This is so important and so fundamental for me that I think everyone should already know it, and yet I still see other developers working on changes or refactoring their code without so much as a hint of testing. Why are they surprised to later find out that their code doesn't work? This diagram shows efficient development in action. We are taking our code through a series of changes, and the key milestone after each change is that we have working code. We do not tolerate broken code, so whenever we find it, whenever we detect broken code or a problem or a bug, we fix it and we immediately return our code to a working state. That is the priority. Editing a bit of code, but then bringing it as quickly as possible back to a working state. You might like to think of this as a game that you can play, one where you are repeatedly making changes to your code and then aiming to return the code to a working state as quickly as possible. And you should train yourself to feel very uncomfortable when your code is broken, or even just at those times when you can't prove that your code is working. You should feel uncomfortable if your code isn't working. You have to understand that the natural state of code is actually a state of it being broken. It's almost impossible for anyone to write correct code without testing it. That's because there's so many more ways for code to be broken than there is for it to accidentally be in a working state. Have you ever felt overwhelmed by the complexity of your code base? Well, the inescapable destiny of modern software is complexity. Our products have an increasing number of parts, an increasing number of components with exponentially growing interactions. That's the nature of complexity. But the good news is complexity can be managed. So we shouldn't fear complexity, we just need to be better at managing it. Complication, on the other hand, that's quite different from complexity. While complexity is a fact of life, complications are usually unnecessary. You might imagine that complex products have to be built from complicated parts, but that's not true. It can be difficult to see this, but we can create complex products from simple parts. And there are many benefits to writing code that is simple. For one thing, simple code is easier to understand, and that's great for when other people, or maybe your future self, have to work with your code. The most substantial benefit of coding in a simple way is that it is easier to test, and code that is easier to test is easier to keep working. Getting to a solution quickly, avoiding wrong turns and dead ends, that can be tricky, but if you can figure out where the shortcuts are, you can create a much simpler route to the finish line. For instance, do you really need your code to be perfect? Who even gets to decide what perfection means? Okay and useful is better than almost perfect and not yet ready for production. You should learn where the acceptable boundaries are in your organization. When you know what you can and can't get away with, you will find faster ways to deliver your code. Now let's circle back to this question that I asked earlier. What's the fastest way to write code? It's simple. Just don't write the code. I know this sounds crazy, but if we could use a crystal ball and figure out which of our code is destined for the trash heap, we could simply not write that code in the first place and save ourselves a lot of time. The fastest code we can write is the code that we preemptively eliminate because we realize early that we don't even need it. And it's a sad fact of software development that so much of the code that we write is going to go unused. Here's a less crazy way to look at it. Choose carefully the code that you decide to write. Be cautious where you invest your time. Decide to write code with the most obvious value and be wary of coding something with an unknown value. I asked this question, what's the fastest way to write code? Because I hope it made you think and because it highlights something important about prioritization. Thinking about where you can deliver the most value, thinking about where the best place is to invest your time, these are the kinds of thoughts that put you on track to being a more effective developer. So we've talked a little bit about the philosophy of rapid development. Now let's talk about the ingredients that we need for the development process that can make this a reality. At the heart of our personal work iterations is the coding cycle. Each small trip around our coding loop should produce working code. So we code a bit, we check the result to make sure it's working and fix any issues. We code a bit, we check the result to make sure it's working, we fix any issues, and so on. We are coding in small increments and testing and assessing the results each time. Why are the increments small? It's because small increments of code are easy to achieve, they are easy to test, and they're easy to prove correct. Testing is how we know that our code is working. I like to say this: if something is worth coding, it has to also be worth testing. Testing is a non-negotiable part of development. It is your responsibility to test your code and be sure that it works. When coding is done in small increments, the testing is easy. If you only write a few lines of code, then you only have to test those few lines of code. This is how testing is meant to be. It shouldn't be difficult. Coding and testing are supposed to fit together easily like this in a tight loop. Testing only becomes difficult if you bank it up to do later. It's only when you unfold the coding cycle over a longer period of time you can really see its power. Imagine this sequence stretched out over hours, days, or even months. We start from simple beginnings, possibly just a single line of code. Then we work through a series of small changes. Each code change is small, simple, and easy to test. At no point in this sequence is testing difficult or overwhelming. That's because we baked testing into the heart of our coding cycle. Through this series of simple changes, we accumulate a large body of working code. We're building up step by step to a complex application. I just want to add, because this might not be clear otherwise, the duration of the coding cycle is usually shorter than the duration of your personal work iterations. So you can see in this diagram that there are multiple trips around the coding loop for each Pomodoro. So when I'm doing Pomodoros, every 25-minute block, I'm doing multiple loops of the coding cycle. With each code change, we should aim to bring the code back to a working state as quickly as possible. Working code, not broken code, is the output of your coding cycle. It's what defines the end of one cycle and the beginning of the next. So here's the key idea for speeding up your development process. To accumulate working code more quickly, we must reduce the distance between working states. There's two ways to achieve this. First way is to minimize the size of the change. So that's small increments of coding like we just talked about. The second way, which is also very important, is to minimize the time it takes to test the change and verify working code. This is what we call fast feedback. This simple idea is so powerful and so easy to bring into your own development process. The more quickly you can check that your code is working, the faster you can make your pace of development. I'm going to give you a taste of what fast feedback is in a moment when I do my live demo. And I have a whole talk on my YouTube channel on using live reload to achieve fast feedback. The natural state of code is to be broken, and it requires constant attention to be sure that it's working. Given this is the reality, how do we reliably capture working code? How do we preserve the output of our coding cycle? Well, the answer is version control software, which you most likely know as Git. Git is the most well-known modern and mainstream version control software. So we need Git or something like it to capture the state of our code after we have tested it. Software like Git, it's very useful to developers for many, many reasons. Right now, I'm only concerned with its ability to track working versions of our code. The right time to commit your code is at the end of every small increment of coding. At this point, you've made a code change, you've tested it, and you know that it works. Commit your code now before you break it. Now, you might think this is excessive, but I believe this is the most reliable way to put working code in the bank. Make a small change, test that it works, commit. and then repeat. You're banking working code. This also gives us a lot of freedom. So if at any point you get into a bad situation, like you've broken something, you're not sure why your code isn't working, and you've made a mess of it or whatever, you have a way to back out of that situation quickly by resetting to the previous commit, which you know, because that's the process we're doing, you know that the last commit is working code. I like to think of the git reset as a get out of jail free card. When you discard your working copy, you don't lose much code because you have been only doing small increments of coding, so there simply isn't much to lose. I've been talking a lot about testing, and you might have assumed that I was talking about automated testing. So this question could have popped into your head: is automated testing worth it? The problem is that this isn't really the right question to ask. Here's a better question to ask: when is automated testing worth it? You might be surprised to learn that I routinely use both manual and automated testing in my own development process. The simple answer is that automated testing is often very worthwhile for code that is evolving, and hence, it needs frequent retesting, or maybe for code that needs to be very secure or very reliable. But automated testing, it is a big investment in your code. It takes a lot of time. It is an investment that can pay off because it can remove many hours of tedious manual testing from your development process. But you always have to ask the question, is my code worth it? Is my code worth the investment of automated testing? Only you can decide this. In my book, Rapid Fullstack Development, I will help you understand how to make the decision. In just a moment, in my live demo, I'm going to show you what it looks like to run a suite of automated tests. So what's JavaScript got to do with it? Well, this talk and my book are both called Rapid Fullstack Development. Fullstack development, it is at the heart of what I'm talking about. Even though a lot of these techniques I've been talking about, they can be generally applied to any kind of software development. But let's start by noting that JavaScript is the only programming language that is truly full stack. Of course, if you're building a front end, a browser-based front end, you have to use JavaScript to build that. But we can also build backends, desktop applications, mobile applications, and more. In a moment, I'm going to show you an example of a mobile application in my live demo. And in my book, Rapid Fullstack Development, I cover all these uses of JavaScript. Of course, I'm also talking about derivatives of JavaScript, like the most famous one, which is TypeScript, which personally I use quite a lot in my own development process. So there's a bunch of reasons why JavaScript can make you a faster developer. Being able to use one language across the stack is very important because it means you can go anywhere in your stack quickly without suffering a cognitive penalty for changing languages. JavaScript is a dynamic language, and that can really help us build a fast workflow. It makes live reload possible. I'm going to give you a taste of that in the live demo. It makes JavaScript great for dynamic and rapid prototyping, working with data. It makes automated testing much easier because it's so easy to mock objects in JavaScript. And then we can layer strong and static typing on top of JavaScript using something like TypeScript. The really amazing thing is that TypeScript can also be very flexible. So it's like we can mix and match the best of dynamic and static worlds. JavaScript has a huge and rapidly evolving ecosystem. For some newcomers, this will be very frightening or overwhelming. But as JavaScript developers, keep this in mind, we are very privileged to have such great tools at our disposal. We can pick and choose the tool set that best facilitates rapid development. We can select the tools that help us move faster and avoid the ones that slow us down. We also have some of the best tools of any programming ecosystem, and our tools are always improving due to huge community engagement. In particular, I want to call out some of the automated testing tools like Mocha, Jest, and Cypress. Testing in JavaScript is an absolute joy, and it's part of the bedrock of my own development process. Okay, it's time for a bit of a live demo. I'm going to show you some of the things that I've mentioned in this talk. Before I get into it as well, this is the webpage for my book, Rapid Fullstack Development. You can get to it yourself at rapidfullstackdevelopment.com. Please have a look. Chapter 1 is free to read online, so please have a look at that, and you can subscribe for updates. The first thing I'm talking about, or the first thing I'm showing in my live demo, is the test suite for DataForge. DataForge is my own library for doing data wrangling and data analysis in JavaScript. It works in both node.js and the browser. You can look it up on NPM, or you can look it up on GitHub if you want to try it out for yourself. Here I am in my terminal. I'm going to run my tests. So by convention in Node.js, we run npm test to run our test suite. This is using Mocha, which you can see here from the command line to this big command line. I didn't have to remember any of that. I just have to remember npm test. So npm test is the convention that saves you having to remember the individual command for running the particular test suite. This is one thing that can help make you a faster developer, is to understand and use the conventions in your platform. Anyway, that was the test suite running. In fact, I'm going to zoom out so we can get a bigger view of this. So there were 777 passing tests. It took 2 seconds to run that. Do you even believe that? That's pretty fast. Let's run that again, just to check that. One second. So this is what I'm talking about with fast feedback. I am exercising almost every possible facet of this code in 1 second. And it's a fairly large library. There are thousands upon thousands of lines of code in this code library. I've spent many years building this up. Now I can run this in live reload mode. So if I do a run test watch, so this is the command that I use. This is my personal convention for running it in watch mode. So now that it's run all the tests, you can see it's just waiting for changes. So I'm set up now to start coding, to start changing this code, adding new features, editing the code that's there, whatever I'm going to do. It's automatically going to retest and show me. So this is a little bit harder to do on a laptop because there's not as much screen real estate. But I can get Visual Studio Code and I can get my automated tests side by side. Normally I work on a desktop where I've got a lot more screen real estate to be able to do this kind of thing. But I can make changes here. So what happens if I break this? What happens if I accidentally like a different number here and I break that without realizing it? That's a pretty trivial mistake to make. I would hope that I would understand that. Put in something wrong in my code and just pretend I didn't realize that I did that. My tests will immediately tell me that something is wrong. At least one test is failing. I've got a failing test. I can easily fix that. And I've got all my passing tests again. This is fast feedback, live reload in action. I can change my code. I can add new features. I can edit the code, and it will immediately tell me if I've broken something, if I've done something wrong. I'm just going to show you a git reset, actually, because I think, I promised I'd show that. Now, let's say that I've broken this code. I know what I've done. I mistyped a number here, but sometimes you're going to make a big change to your code and you're going to break something badly and you're not going to know why. And you could spend hours trying to figure out, what's wrong with it. But the simplest way to fix it is just do a git reset, right? So, know what's there, know what you've changed. Let's just pretend that I can't figure out what's wrong, even though I can. If I do a git reset hard, that takes me back to the previous working commit. So if I do a git status, nothing has changed. My code has been reverted. My tests now should run. So I did a git reset. I'm back to all passing tests. I reverted my code. I lost some code. But because we're doing small commits, small code changes, small commits, when we do a git reset, we're not going to lose much code. Now let's do a quick example of doing some testing after the fact. I wrote a large part of Dataforge using test-driven development, which meant I wrote the code for the tests first, and then I wrote the code for the features of Dataforge that would allow the tests to pass. You don't have to work that way. TDD, test-driven development, is great for a lot of reasons, and it can teach you some really great skills to do with testing. It can be a really good discipline to make sure that your testing does happen. But at the end of the day, what you want is the tests. It doesn't matter whether you did test first or test last. You just need the tests. Let's pretend, I'm going to show you a quick way to put a test in place. Let's pretend that, I don't have this test, and I'm going to rebuild that test. Let's say, in this case, I'm testing the standard deviation function of Dataforge, and I looked at a maths textbook to figure out how to get that to work, how to do that. And I'm confident that I got the code right. I've tested the code manually, maybe. I didn't do TDD, but now I want to put a test on it. I want to write this test. The interesting thing is that you can just write it. You can just write it after the fact. Call it the standard deviation test. Save a bit of time. And I'll reuse this input here that I've got here. So I'm really just re-implementing this test, but showing you how I could do this after the fact. So these values are the input values that I got from the textbook. I might want to actually create a series from that, call the standard deviation function. And then I'm going to expect that my result is equal to something. But the question is what? What is it going to be equal to? I mean, yeah, I could look that up in the textbook, but maybe not to the precision that I want or something like that. How do I do it? Well, the simple reason is just to put in any value. Let's put in the meaning of life, 42, which is clearly going to be wrong for this test. But when I run this, when I save this and it reruns my test, guess what? It's going to tell me what the answer is. It's going to say, it's not 42. This is the answer here. So I'm using the code that I know works to tell me what the answer is that should go in my test. So this is like the cheating way to write tests, is to write the code, manually verify that the code works, and then write the test. It's an alternative to test-driven development. Test-driven development is great as well, but we don't always get to put that amount of investment in our code that we can do that. Now for the next little example I'm going to show you, we're going to use my TypeScript template. So here is my TypeScript template on my GitHub page, Ashley Davis, TypeScript template. This is a great starting point for a new TypeScript application. So it's got all the boilerplate you need for TypeScript. I use it as my TypeScript testbed. So whenever I'm working with TypeScript code in a bigger product, in a bigger library or a bigger application or something like that, and I want to debug some code, or I want to kind of experiment with the code or make an experimental change to it, I will use a testbed. I will use just a really simple application where I can transplant the code from the bigger application into the testbed. The reason I like to do that is because when you're working in a bigger application or a bigger code base, there's a lot of baggage. There's a lot of things you have to deal with and have to remember and have to do, and it can be slow to start, it can be slow to build, all these types of things. So it can be a very effective technique for your own development process to take the code that you want to play with and put it in a testbed. So I've got my testbed open already in Visual Studio Code. And now this is just the default. This is just part of the template. It's just some example code. I don't really care about that. But what I want to do here is, let's say that I've got a function where I want to play with the guts of this function, right? Yeah, just do it. Just copy it. Just copy it and put it over. And you're probably saying, how can this possibly work? It's got all these dependencies. The code's all broken. Well, we can take out the dependencies one by one until we get maybe this bit here. Maybe this bit here is the bit we're interested in, right? How do I do that? Like, I've got to replace this with something. I could pull in the whole mean function. That's one possibility. I could pull in the whole, but there's dependencies on dependencies here as well. So maybe I don't want to bring in all these functions, but I can easily determine what these functions are. I can just console log them. So I can console log what the mean is here. I can console log what the standard deviation is here. I can also console log what the input is. So console log this.toArray should do it. Here I am back in my tests. I'm just scanning back through the tests looking for the output. Here it is. I can see that input. I can see that mean. I can see the standard deviation. I'm just going to copy all of this. So I'm letting the code, the existing code, tell me what values I need to work with. Now I'm going to plug these values into my testbed. The input, this is very simple input, but it doesn't matter. It could be more complicated than this depending on what you're trying to achieve. I'm going through and I'm replacing these values, with the dependencies that I've got in the code. I don't need that bit of code there. And let's just get this result. Save that to a variable. And I'm just going to console log that variable. So I've successfully just pulled out maybe a little bit of code that I want to play with. I'm going to run that at the terminal now. npm run start to start in live reload mode. So I'm just running this TypeScript testbed from the command line here in live reload mode, so I can change the code as I see fit and see the results come up here. That is the console log that I'm getting. You can see here that I've pulled out this code to a testbed. It's just going to be a little bit easier to play with the code in the testbed. That's all. That's the only reason I did that. I've discarded the entire baggage of whatever application, whatever code base this came from. And you can do that yourself as well. And sometimes it's not going to be that easy. It's not going to be that simple. You're going to have to get more code working. If you're trying to solve a difficult problem, it's probably going to be easier to solve it in the testbed. I've got one last thing I want to show you, the Ionic application. So this is an example of a mobile application developed using web technologies. I'm already running it in my terminal. So this is the main Ionic webpage, ionicframework.com. It's a great tool set that allows you to build mobile applications with multiple web frameworks. Personally, I like to use React, but they also support Vue and Angular. Because it's a web application, you can test it in the browser. That's what makes this such a rapid process to build mobile applications, is that you can do most of your testing in the browser, and then when you're ready, you can compile this out, export this out to a native mobile application that you can run on device. Now, the nice thing about Ionic as well is that these days, in the modern incarnation of it, you can actually write whatever native code you want as well. So if JavaScript isn't enough, if you need to access things like native APIs on either Android or iOS, you can actually delegate that to native code fairly easily using Ionic. Use web technologies for the most of it for a really fast development pace. Use native code when you need the native code. I recommend reading the docs. So all I've done really in this demo is to create a very basic Ionic application, based on one of their starter kits. So you can choose a starter kit down here. This guide here tells you how to get up and running for yourself, and within a few minutes you'd be able to achieve what I've achieved with it. So this is what the Ionic application looks like in the web browser. It's like an email client or something like that. It's pretty simple. Now, if I go into the Dev Tools in Chrome by hitting F12, I can turn on the mobile form factor. So we're seeing it here as if it was a mobile application. So that's a great way to test it. I've already got the code for this Ionic application open in Visual Studio Code, and I just want to show you how easy it is to update a mobile application using web technologies. So I'm just going to add a hello world to this. And I'm saving it, hello world, in the browser. So I'll just change this to hello computer. And you can see there almost instantly it changes. So that's fast feedback in a mobile application. This is just in the browser, but I can easily export this to run on an iOS device or an Android device. So I'm basically done now. I just want to summarize the key things that you can do to create a faster development process. You should be coding in small, well-tested increments. Small amounts of code are easy to test. Put the highest priority on keeping your code working and don't tolerate broken code. Capture your working code in version control so that you don't lose it and so that you can quickly back out of difficult situations. Automated testing doesn't always make sense, but often it does, and it will save you a lot of time doing that tedious manual testing. My best advice is to learn through doing, and that's why I'm writing my book, Rapid Fullstack Development, because I want you to experience this rapid development process for yourself, and I have much more to say about getting fast feedback, automated testing, refactoring your code, debugging your code, and much more. So please check out my book. Please join me on Twitter, and thank you so much for listening.